In this video, we take our first look at the three logic gates you need to be aware of for the GCSE exam and simple logic diagrams. By using binary digits, you can build electric circuits to process data. Circuits are built using components that carry out Boolean true or false operations. Here's an example of a circuit that can add binary numbers together. Now this is more complex than the circuits you need to study at GCSE, but it illustrates their use. You will notice that the circuit is built using three types of components or Boolean operations. We sometimes call these gates or logic gates. There's a NOT gate. There's two examples of an AND gate. And there's an OR gate. Let's explore what happens to the signal entering and leaving each of these gates to better understand how they work. So first of all, the NOT gate. The NOT gate is very straightforward. We can either supply it with a naught, so you can think of that as meaning no current is supplied, or a 1, which means an electrical current is being supplied. The NOT gate simply reverses the input. So if a 0 is input, a 1 is output. If a 1 is input, a 0 is output. The second gate is an AND gate. Now this gate takes two inputs. Like the name of the gate suggests, both of these inputs need to be on. They need to have an electrical current. They need to have their inputs at 1 for the output to be 1. So if both inputs are 0, the output is 0. If only one input is a 1, so only one input has an electrical current, the output is still 0. Same if we swap the two inputs. It's only when both inputs receive a current, so they both have a 1, that the output is also 1. The final gate is an OR gate. Again, as the name suggests, we have two inputs, but either of the inputs can be on for the output to be on. They don't both have to be on. It's one or the other. So in this situation where both inputs are 0, the output is 0. Now we have at least one input as a 1, the output is 1. The same if we switch them around, and indeed the same if they're both on. We have seen that we can combine these various logic gates to create logic diagrams, and this is something we're going to cover in more detail in another video later in this series. Now we've been writing the words AND, OR and NOT inside the logic gate symbols, but they're not going to do that for you in the exam. So the first time you get introduced to these, it can be a bit tricky remembering which gate is which. So we're going to show you a simple trick. There are many others out there for helping to remember which gates are OR, AND and NOT. So this is an OR gate. And one way to think of it is that the back of the OR gate, the curve, forms the right hand side of the letter O for the word OR. This one is an AND gate. And you can think of it as being the letter D of the word AND, a capital letter D. And finally, this one is a NOT gate. And you can think of the start of that gate as being the letter T. It's the only gate that could possibly be the letter T because the other two take two inputs. So that's everything you need to know for the GCSE exam done. You can stop taking notes now. But if you wish to know a little bit more about some of the other logic gates that are available and that you'll learn at A level, then you can carry on watching the rest of this video. So as you can see, we've got the AND, OR and NOT gate across the top. And these are gates that we've been learning about in this video and you need to know for the exams. But there are many other gates available, and 3 below are typical gates that you will learn in the A level. The first one here in the bottom left is a NAND gate, which stands for not and. It effectively is the same as tying an AND gate and then a NOT gate together in sequence. So effectively, whatever would come out of a normal AND gate then gets reversed before its output. The next one is an XOR gate. This is called an exclusive OR gate. If you remember, an OR gate outputs 1 if either of the inputs are 1 or if both of the inputs are 1. With an exclusive OR gate, it will only output 1 if one of the inputs is 1 and the other is 0. It wouldn't output 1 if both of them were 1. And finally, we have a NOR gate or a NOT OR gate. In a similar way to a NAND gate, this is exactly the same as tying an OR gate together followed by a NOT gate in sequence. It effectively flips the output.